we have the ideal gas equation PV is equal to nRT. To get the value of R, you have to transfer N and T on the other side of the equation. So here you will get R is equal to PV over NT. It is the gas constant and its value is same for all the gases, but the unit depends on the unit in which pressure, volume and temperature are measured. Now let's calculate the value of R in bar, liter per Kelvin per mole. So here temperature is 0 degrees centigrade. First of all, convert this temperature into Kelvin by adding 273.15 to it. So here you will get 273.15 Kelvin. Pressure will be 1 bar. And at these conditions of temperature and pressure, volume of 1 mole of gas will be equal to 22.71 liter. Now we have the equation R is equal to PV over NT. Now place the values in this equation. So here you will get R is equal to 1 bar multiplied by 22.71 liter divided by 1 mole multiplied by 273.15 Kelvin. On solving it, you will get 0.08314 bar liter per Kelvin per mole. Now calculate the value of R in atmosphere liter per Kelvin per mole. Here we have taken the temperature 0 degrees centigrade, that is equal to 273.15 Kelvin. Pressure will be 1 atmosphere. And at this condition of temperature and pressure, volume of 1 mole of gas is equal to 22.414 liter. Now place the value in this equation. So here you will get R is equal to 1 atmosphere multiplied by 22.414 liter divided by 1 mole multiplied by 273.15 Kelvin. And on solving it, you will get 0.0821 atmosphere liter per Kelvin per mole. Now find the value of R in Pascal liter per Kelvin per mole. We just have calculated the value of R in bar liter per Kelvin per mole. 1 bar is equal to 10⁵ Pascal. So when we place the value of 1 bar in terms of Pascal in this equation, you will get 10⁵ Pascal multiplied by 22.71 liter divided by 1 mole multiplied by 273.15 Kelvin. And on solving it, you will get 8.314 multiplied by 10⁻² multiplied by 10⁵. When you solve it, you will get 8.314 into 10⁵ Pascal liter per Kelvin per mole. Or you can directly multiply this value by 10⁵ Pascal per bar. So when you solve it, bar will get cancelled out with bar and you will directly get the answer in Pascal liter per Kelvin per mole. Now calculate the value of R in Newton meter per Kelvin per mole. Here temperature will be equal to 273.15 Kelvin. Pressure can be written as force per unit area. Unit of force is Newton and area is measured in meter square. So when you measure pressure in bar, you will get 1 bar is equal to 10⁵ Newton per meter square. And at these conditions of temperature and pressure, volume of 1 mole of gas will be equal to 22.71 liter. It can be written as 22.71 dm³. 1 decimeter is equal to 10⁻⁻1 meter. Now place the value of decimeter in this equation. So here you will get 22.71 multiplied by 10⁻⁻1 meter whole cube. When you solve it, you will get 22.71 multiplied by 10⁻³ meter cube. Now place the value in the formula R is equal to PV over NT. So here you will get R is equal to 10⁵ Newton per meter square multiplied by 22.71 into 10⁻³ meter cube divided by 1 mole multiplied by 273.15 Kelvin. And on solving it, you will get 8.314 Newton meter per Kelvin per mole. Now calculate the value of R in joule per Kelvin per mole. We just have calculated the value of R in Newton meter per Kelvin per mole. We know force multiplied by distance is equal to work, where the unit of force is Newton and the unit of distance is meter. So the unit of work will be joule. Here Newton meter can be replaced with joule. So you will get the value of R is equal to 8.314 joule per Kelvin per mole. Now calculate the value of R in calorie per Kelvin per mole. We just have calculated the value of R in joule per Kelvin per mole. We know 4.184 joule is equal to 1 calorie. So 8.314 joule will be equal to how many calories? So here you have to divide 8.314 joule divided by 4.184 joule per calorie. So joule will get cancelled out with joule, and on solving it you will get 2 calories. So the value of R in calorie will be equal to 2 calorie per Kelvin per mole. So in this video we have calculated the value of R in 6 different units, and here I have summarized all different units and values of R.